Hey everyone, hello. I'm here with Kristen Findlay. Findlay, is that how you pronounce
Findlay,
Findlay?
yeah.
Findlay.
Right.
And we are going to be talking about testing. But before we do that, Kristen, why don't you go ahead and introduce yourself?
Hi, nice to meet you. I'm a Flutter developer in Melbourne, Australia. I've been developing software for about 20 years, and you can check out my website, christianfinlay.com. I'm currently available to build Flutter apps at the moment. I'm talking to you today about testing because it's something I'm pretty passionate about. I've been doing it for a long time. One of my first jobs in the software industry was automated testing. So I did that a long time ago. And so rather than coming from a programming background, I started out in the testing sort of area and worked my way into programming through automated testing. So I wanted to talk to Azam today about this because I think we have pretty similar thoughts about that, and I think we can come up with some good discussion about that. So yeah, over
Sure.
to you.
Yeah, and my introduction will be like mostly my name is Mohammad Azam. I work as an iOS developer, and in my day job, I teach web development for a coding bootcamp, and I do a lot of Udemy courses on iOS development. And I'm also obviously very interested in testing and um, trying to find those small places where, well, not small places, but yeah, trying to find like pragmatic way of testing, in other words. Okay, and this will be our mostly like I would say informal kind of a discussion regarding testing. So why don't you, Kristen, start with definition of, I guess, or should we go ahead and start with, yeah, definition of unit testing so
Yeah,
that
sure. Sure.
everyone will know what actually unit test actually means in our case.
Yeah. So everyone's got different definitions, and I don't want to step on anybody's definitions of what it means, but we just need some common language. And the words that we usually use are unit integration and end-to-end testing. So what that means for me is about the level of isolation. So when we talk about unit testing, there are a couple of different, schools that you can talk about for unit testing, but it's basically focusing on a single part of the system. So a single class, a single function, something like that. Whereas an integration test, from my point of view, typically means multiple moving parts together, so multiple units, and that could be the entire app, working together with composition, everything working together. And then for me, moving up to the end-to-end level sort of means that we could involve external systems, we could involve a database, although that could be, an integration test could involve the database as well. But an end-to-end test would, for me, mostly means no mocking involved whatsoever.
Yeah,
Whereas I think for an integration test, I would consider that, there could be some mocking involved in that. So does that
yeah.
sort of match what
Yeah,
you think?
yeah, yeah. That's exactly what my definition would be. Um, and unit testing, I would say, and we'll get to integration testing and end to end, but beginning with unit test is when you said about covers a very small unit of the application, and
Mm.
it does it in isolation. I think the word, for me at least, the isolation word, people kind of like literally takes it for like, oh, it has to be completely isolated. It
Yeah.
cannot touch the database. It cannot touch the file IO. So at least my thinking is doesn't go there. My thinking like, hey, if you want to touch the database, go ahead and touch the database. If you want to touch the file system, go ahead and do that. But just remember to revert it, roll back it once the test is done. So that is where I think at least my definition is, or my definition of unit tests might be a little bit different from other people who are like, no, you cannot touch the database, you cannot touch the file. It has to be under 1 millisecond, or else it's not even a unit test.
Yeah.
So those kind of things. So what do you
Yeah.
think about that? Like,
Yeah, well, look, if you have, like, for a typical example is a repository, right? So if you have a repository, let's say you design your app and you have repositories. If you test that repository, right, you are talking to the database. So I would call that a unit test because you're isolating the repository itself. You're testing the repository code.
mhm,
Um, I don't want to get hung up about the definitions,
mhm,
what you should or shouldn't do. But at the end of the day, if you have code, you have to test it. right? So it doesn't matter if it talks to the database or it talks to a third-party system, you still need to test that in some way. And if you have a repository, for example, or any function that loads data from a database, you need to test that. And the best way to test that is to hit the database.
Absolutely. Yeah. Yeah. And I think the other thing is, for me at least, the unit test usually, for me, it works when you are trying to solve some sort of an algorithm related question. This can be the actual domain of the application. Like for a banking application, it can be withdrawing the funds, transferring funds, deposit, and penalizing people if they have insufficient balance. So those kind of things should be quick algorithms to test using the unit test. Obviously, then you'll have to write end-to-end test and all that to test the whole thing. But those will be the small unit tests you will write for algorithm related stuff.
Yeah. There's a lot of cases where unit tests just make sense. There was a case recently where I had to mask phone number input for some reason. The library wasn't working, so I had to write a function. So the first thing I did in that case was write, the criteria. So I did test first. I wrote all of the inputs and outputs down, set up the test. Then I wrote the function and made sure that the function, passed all of the tests. So that was a case where unit testing just kind of made sense, and it was quick. It was easy to get that working. And then inside the app, that also overlapped with the integration tests inside the app, so I could use that. But it allowed me to target that functionality quickly and easily, which is good. But at the same time, I think that unit tests have a bit of a limitation, which is, I think, what we're talking about today. Right?
Yeah. And I think, for me, it also clearly depends on the domain that we are working on. If I am, and this again will be very controversial, but if I'm working with a domain that I'm very comfortable with, it's not really a complicated part of the application, then I might not even write any unit test, and I would probably eventually it will be tested using end-to-end testing. If there's a long happy path for end-to-end testing or manual testing. I sometimes I use manual testing also. I know that Flutter has that hot reload thing. You can quickly do those testing for the UI and all that logic related to the UI. And in Swift UI and Xcode iOS, we do the same thing. So you can quickly test some logic, through the UI, I guess. But yeah, it really, for me at least, it depends also on the domain. If I'm not familiar with the domain, then I'm like, okay, I need to write the test. But if I am familiar with the domain, then I'll just do manual testing. I'll probably run a couple of times.
Yeah. So I think the thing about the domain is about risk level, right? So if you are working, like you said, with a bank, you have to have many levels of testing, right? So the more levels and the more redundancy, well, I wouldn't say the more redundancy, the better, but what I would say is that, redundancy is more acceptable in a banking system, for example, right? Because, what we know, code is a liability, and test code is a liability, right? The more of it you have, the more you have to maintain. So what we need is the most efficient way to test the app without making it so onerous to maintain the tests that we can't write the tests. And I think this is the biggest complaint or the biggest pain point that I hear from so many people about testing is that, to get a full level of coverage, a lot of people are writing hundreds or thousands of tests and never really reaching a true level of code coverage that actually covers the system. If you're working in a bank, it kind of makes sense. You probably want to have thousands, tens of thousands of tests to prove that every little moving part is exactly correct. Because, if a dollar goes missing here or there, that's a big deal. There's a big problem in the system. But for what we normally do, for most apps, the most important thing is that the app works, that it doesn't crash, that the user can perform their workflow, that they can go from point A to B inside the app and the desired outcome happens. And frankly, I think somewhere along the lines, that point got lost in testing somehow. And from talking to people, when I look back on my days of testing and automated testing versus what people do these days with unit testing, the thinking is very, very different. When I was first writing tests, I was in the QA department and I was writing automated tests. The goal is to make sure that the software works. The goal is to make sure that it does what the user wants the software to do. That's always been the job of testing and automated testing. Automating testing is really just about automating that process. But when you skip forward and you think about all of the baggage that comes along with unit testing and the processes around unit testing, that is very different. What we talk about these days is often very much like, it comes from a point of view of code design. Why do we test? We test because we want to make sure that the code is designed in a certain way. For example, solid, for example. Yeah. So the kind of the causality is kind of reversed in that situation. Rather than testing for the purpose of making sure that the app works properly, we are, designing code so we can test it, and then testing code so we can design it. It becomes a kind of a circular way of looking at the testing process. And so the way I think is very much like the traditional idea of testing an app to make sure it works for the user, and then automating that. That's how I think about it.
Yeah, I think you're 100% right, because I think what has happened is that people are giving the equal priority to all the different features that the app is providing, and it's not. Like, some part or some code is much superior than the other code. The code for a bank, which is very important, is depositing, transferring, withdrawing, and insufficient balance and charging penalty, because I think they make like a $5 billion of just charging penalty and fees. So that's much more important than writing or investing a lot of time in writing a code for some sort of a logging thing that developer has created and it only logs something. I mean, that's important, but not as important as writing tests for the business cases. And I would even say, like, if those functionality like logging and everything that the developer is writing for themselves is not even exposed to the customers, then don't even write tests for it. Just do it like manual testing and you'll be fine. And invest more time in where the real money is, which is like all the actual things for banks. And as you were saying, that I've seen this, and there's like a lot of stuff going on in different groups that I read about, that, well, why did you use this pattern? Well, because it's easier to test. Well, you have to add, like, why are you adding this interface or a protocol? Because it's easier to test. Well, there's nobody conforming to that protocol. There's only like one person. So why not just use a concrete class? Well, I have to use it because so I can mock it. But why do you have to mock it? You own the dependency. That's a managed dependency. You can just hit the real thing. Well, but that will not be a real test. And it goes into like circular, discussion and debate all the time.
Absolutely. Yeah. So just to sort of be clear, I think this is where our thinking might diverge a little bit, because I do use mocks and I do use dependency injection. But I very much think you're right that where possible, it's great to use the real thing. And I think that, you've already got me thinking about that a lot more. And I'm already thinking about ways that I can, introduce the real dependencies rather than using mocks. But I still kind of have a sense that mocks can be useful for certain things. I think just in the case of certain code bases I've seen in the past, that you have a huge amount of tests. And if those tests include database tests that hit the database, they're just too slow to run altogether. So in some way, you still need to be able to run the entire test suite in a reasonable time frame. But saying that, most of the time, the reason why those tests are slow is because, you know, there's massive redundancy, that the code is not optimized. There's various reasons why, you know, there's just so much code and so much redundancy that it just takes too long to run that. So I think, you know, if you've got a test suite that is just too long, just takes too long to run, it's probably not because you're running database tests. It's probably more because you have a massive amount of redundancy, or the code is not optimized, or those kinds of issues. You know,
Yeah.
that's my thinking. Yeah.
Yeah, I think a couple of days ago, I was working on just a dummy app, and for looking into these testing things and scenario, and I was kind of like limiting myself. Okay, this is the API for a movies database. I don't own it, so it's unmanaged, so I cannot hit that, the real thing. And so I was just limiting myself, like, okay, every time I'm going to hit the movies real API, it's going to cost me 25 cents. So I can't do that. So that's out of the question. So how can I do it? Using mocks or stubs.
Yeah.
But since it is just the data that I need, I'm not really doing any incoming data. It's mostly coming from the outside into my app. So mocks, I don't really need it. I just need stubs because I just need the data. So in those cases, definitely I introduce a stub mock. Well, stub in that case, because mock is a little bit different from stub, because mock actually verifies the behavior, while stub just give you the data you need. So in those cases, I had to use a mock, a stub, and I had to use those dependency injection, and I had to create a protocol just for the sake of, so I can test this thing.
Yeah.
Yep.
Yeah.
So.
Yeah. So I guess the thing is, Firebase comes to mind here because Firebase has an emulator, and that's fantastic because you can run Firebase on a Docker container, and you can test against basically the real instance. As far as I know, the emulator is pretty good. I think it's pretty much exactly like the real thing. Google, you know, this is a Google thing, so it's pretty. I'd say it's pretty solid. And the thing about it is, it does require a little bit more setup. You do have to understand Docker. You have to understand how to install things on Docker and run things in the pipelines. So there is more configuration there. But imagine a situation. Imagine being able to write code where you don't have dependency injection. You don't have to replace the code with mocks. You write some code that literally talks to the database, and because you know the state of the database, you know what the result is going to be. Imagine that. Imagine being able to throw all those patterns for dependency injection and your IOC container. Or throw. By the way, I have a library for Flutter called IOC container. So I use dependency injection all the time, but I only see it as a necessary evil. You know, from what I've seen in the past, you know, we do it so that we can test. But if we can avoid that, then I welcome that, and I think that we should be all trying to get to a point where we don't need dependency injection for those things.
Yeah, I think a good example can be if you're building a Flutter application and it has a local database on the device, SQLite or whatever. Now that is, I believe, a managed dependency because it's just local to the device. Nobody can touch it. In those cases, I don't see any reason to mock or stub or anything. Just hit the real database, get the stuff, insert the stuff. Just make sure to delete it after the test is run so that it is in a valid state, or in a state that the next test can also run. So,
or with SQLite, you can just wipe the database completely and start with a clean slate every time to make sure there's nothing.
So having on that point, I do have one interesting question. A couple of days ago, I was working on the same app, and I was trying to do, it was a movies application, and I stubbed out the API because I don't control the API. And I was trying to filter the movies based on the name of the movie. So if I write Batman, it will only show me Batman movies. If I write Superman, it will only show me Superman. So that was just a very small function that I wrote in my view model. And now I have two choices. should I write the code for my view model so that to check that knowledge with the stub? So I did that and it was working. But then the interesting part was that I was thinking, should I even write a test for end-to-end eventually when I have to test the whole thing out? Should I even write the test end-to-end, or should I just be happy with the integration testing I did? So I mean, I don't have the answer of that. So yeah.
I have an opinion on that.
Mhm.
So my thinking is so one reason why I do use dependency injection is so I can replace things with a mock or a fake, right? But I try not to wrap something like that in a service and then mock the service. I try not to do that because you're not testing the HTTP client call, for example, right? Because if you put a service over the top of the HTTP call, you're cutting out some of the testing there, right? If you write a service that that makes that HTTP call, well, it could be that the API is a post, but you're making a GET call, for example, right? So what I like to do is I like to put in a stub or a mock that only mocks the HTTP call. So I don't mock the service, I just mock the HTTP client. So Flutter has a fake HTTP client. So I can say, if this request is made, then give it this response. So this is as close to the to the HTTP protocol as you can get, and that's the only thing that I mock. However, what I can also do is I can put a flag in to say, okay, if I'm running with mocks, then replace the composition with this mock client. Or if I'm running against the real thing, so if I want to actually do a test run with end-to-end, I don't turn that flag on, and then in that case it will hit the real API and get the same result. So I can have tests that run either just as an integration test, like a local integration test, or as a full end-to-end test. And I can do the same thing with database calls as well. I've done that with SQL Server in .NET. So an API, for example, I can run the whole composition of the API with just a few mocks to the database, so it runs very quickly. Or replace that with calls to the database. So you can toggle between the two things. And so in that way, I don't tend to think of it as an either or. You don't have to say, okay, this test is going to be, a unit test, and this test is going to be an end-to-end test. I don't even think about it in those terms. I just think in terms of, okay, here's a test. If I want to mock it, if I want to run it as a mock test with just mocking the database, I can. If I want to hit the real database or hit the real HTTP call, I can. It's the same test, if that makes sense. And that I find that's a good way to work, with both where possible.
Yeah. Because I think the example, another complicated example can be if we're building an app for hotels and people can search using many different options like, I don't know, like landmarks, closest to me, price, Wi-Fi, free breakfast, and all these things. So there are like 10 different filters that you can do on a hotel. If I'm writing an end-to-end test for this from, let's say that this is a managed dependency. I own the hotel database and the API, everything I own. So, and it's running on my local machine. So the whole database is running on my local machine. Well, a copy of it actually, so that it's a managed dependency. Even in that case, I would probably have to test the actual filter logic so that I know I'm getting the correct result. So when you pass in the filter, I need Wi-Fi, parking, free breakfast. Okay, so it will return me 3 hotels. And if I do Wi-Fi and parking, it will return me 5 hotels and so on. But once that test completes, and that we can use a mock, we can use a real thing because it's a managed dependency, we own it. I will probably go ahead and have to write an actual end-to-end complete test and just choose one long happy path where
Yep.
out of 10 filters, I will select 8 of them and see what's going on, right?
Yep.
Yeah.
Yeah. I basically I approach it in the same way. Yeah.
Mhm.
Yeah.
Yeah. But I
So
think go ahead. Yeah.
if I own that dependency, if I'm managing the API, then I would have a lot of tests for that API itself. And those tests would test all of the different parameters, different input permutations of the parameters and things like that. If it's an external dependency, something outside, well, I guess I would probably pick up a bit more of the testing because, somebody else is maintaining that API. But I don't know how that API is going to behave if I send lots of different parameters. So I think it's really important to have an integration test, or, see, in this case, the definition gets a bit blurry, but I would have a test which directly calls that external system, and I would probably have multiple permutations that call that external system. And I may not put those in the pipeline. I may just run those manually. It's better to run them. It's better to run them in the pipeline if possible, but you can't always rely on somebody else's API. Or like you said, they might charge you for those API calls. So in those cases, I will set up the tests. I'll make sure that when I send this request, I get back this response, and so I will make sure that's working correctly, and I would probably validate the JSON and so on. But I might just run those tests by myself, for example.
Yeah. I think one of the things I notice, especially when I'm writing these Swift UI apps and looking at other people's code, is they are obviously, you need to test the logic. That's the main part. But they are using their view controllers or view models to test the UI, which is like, doesn't make any sense. Why would a model, because that's just an implementation detail. I would more rather be creating a complete end-to-end, a UI test, end-to-end test, and checking if a list is populated or a label is, or an actual button is actually clicked. I mean, so those kind of things are also very important. And I see these kind of tests, like thousands of tests, which are using mocks. Even if they have access to the dependency, they will mock it. And that creates very brittle kind of tests, because now you are saying that a mock function like a get movies is going to get fired. But if I go to that particular dependency and change get movies to fetch movies, but it still returns you the correct thing, it'll still fail.
Yes.
Which is kind of weird.
And I think this is the heart of the issue, I think, and this is what we've spoken about quite a bit, I think. So coming from a .NET background, MVVM is a very popular pattern in the .NET world. One reason why it's very popular is because it works across different toolkits. So you could write code in .NET, in C# that works across WPF, Xamarin Forms, maybe UWP, or some other XAML-based technology, right? And the conventional wisdom in the .NET community is to do testing on the view models, the MVVM view models. And there is something valuable about that, because you can test the logic across platforms. But as you say, you're not testing the app. You're testing the logic. So you're testing that the logic is working correctly. But who's to say that the app is correctly calling the logic? If you have, as you said, if you have 3 different methods that do similar things, maybe you meant to use the first method, but actually the app is using the third method. So it could be just completely wrong. The UI could be doing completely the wrong thing, even though your view model is doing the right thing. Your view model could be completely correct, and the app can be still completely incorrect.
Absolutely.
And so moving over into the Flutter world, Flutter has something we call widget testing, right? So widget testing is basically very similar to what we think about automated UI testing. What I used to do was automated testing. You test the UI, so you send messages to the UI itself, and then you validate how the state of the UI changes. It's black box testing. You don't know anything about the internal state of the application, and you don't care. All you care about is what the user experiences. And when I'm looking at Flutter, the good thing about Flutter is that as much as possible, I tried to keep it in that black box area. So I use the app in the way that the user uses the app. I tap the button, I enter the text, or I click the drop down, or I use it exactly how the user would use it. And then the test code that I write validates what the user should see as the user sees it. I don't care what's happening underneath. I don't care what the view model is doing, because that's an implementation detail. It's irrelevant to me. As a user, I don't care what the app is doing on the inside, right? Saying all that, Flutter's widget tests do give me the opportunity to put a mock in places, so that if it's talking to the database, the tests still run quickly or whatever, if I want to do that. So it's not completely black box testing, but I'm following the principles of black box testing, which is that I want to know, is the app doing the thing that it needs to do? Is it giving the correct response for the user? And I think this is, again, going back to what we were talking about before, this is where a lot of the message of testing gets lost now, is that we get lost in the idea of testing the lower levels, the implementation details of the system, testing the units of code, as opposed to making sure that the app is doing the correct thing for the user.
Absolutely. Yeah. And I've seen, as you said, I've seen hundreds, and I'm sure you have also seen Flutter, ecosystem or community, hundreds of tests that I've seen which are taking a view model, and just testing the UI through the use of the view model, that I click a button. Well, you didn't click a button because you actually didn't. Just to confirm, because it's been a while since I actually looked at Flutter, widget testing, does that mean that you are going to run the test? It's going to start a simulator or emulator and then click a button, or how does that work?
Good question. Flutter, you can run those tests in two ways. It's kind of two modes. There's widget testing and there's integration testing. This is a different definition of integration, but a widget test is, for the most part, platform agnostic. So it should run the same on Linux, macOS, Windows, Android. Well, you can't run on Android, but on a desktop. So it's not really targeting the platform, and you don't have access to things like the disk on the platform. Then you've got and also you can't jump the network boundaries, right? So it's more like a pure unit test in that way, but it does test the UI. Then you've got integration tests, which run on the actual device. So you can run an Android test, an iOS test. You can run a desktop test, so you can test it on macOS. You can test it on Windows. So that takes on the characteristics of the operating system. You can access the network. You can talk. You can make HTTP calls. You can access the disk. But you can run the same tests on either way, right? So if you are running a widget test, you have to mock, because you can't talk to a external system, right? And the reason you can't is because you're not using the operating system. You're using kind of like a cut down version of it, and the test would just crash if you try to talk to an external system. It says, no, you can't make a HTTP call. So the tests slide, the same tests slide backwards and forwards between, being an integration and an end-to-end test. So you can run an Android test, and it will literally talk to the external system. And I think this is a very good setup. It's very powerful. And for me, the Flutter community is still stuck in the old way, It's still bringing the baggage of, you know, the MVVM sort of way of thinking into the Flutter ecosystem. But what I'm trying to say is, no, this is a clean slate. We have a clean slate now. We have the ability to make full end-to-end tests with Flutter code and to test it with Dart code. We don't need to bring the baggage of isolating the controller, isolating the view model. We don't need to isolate that test anymore. That does not test the app. If we can confirm that the controller's logic is working, but that does not test that the app is working. It's not the same thing. So that's the thing that I want to try and get across in the Flutter community, that, you know, we need to move across to widget and integration tests as the first point of call. And then, you know, we still have unit tests for a variety of different reasons. But first and foremost, we need to make sure that the app is working.
Absolutely, yeah. I think at least in Xcode and in iOS, we have obviously unit testing, and the other one is UI testing, which is kind of like complete end-to-end test if you're going to write. So we don't have, at least I don't know, we don't have any built-in way to test our views. There are some third-party frameworks that you can use to do that. And I think that is maybe the main reason people went with like, oh, let's just test the view model, and so that we call a function on the view model so that it will simulate the button click. Well, if you want to simulate the button click, why not just actually run it on a simulator and press on the button? So that will be much better.
Yeah, and that actually affects the way people design the code as well, because they need the view model to be as close to the user experience as possible, right? So if there's any, so for example, with XAML, like you know, in the .NET world, there's a lot of things you can do in the at the XAML level. XAML is a very powerful markup language for UI, but if you get too crazy with the XAML, then there's a big gap between what the UI is doing and what the view model is doing, right? So if you add any flavor at the XAML level, you risk destroying your tests.
Interesting.
So you know, the further away you get from the view model, the more you have, you know, your tests are invalid. So that actually changes the way people design the view model. They try to make the view model encompass all of the UI functionality. And actually, you know, by doing that, you're actually losing a lot of the platform's flavor and, you know, the UI functionality, because you're cutting down the view model to only what you can represent as a view model that sits across multiple platforms, rather than embracing the UI idioms of that. So, for example, WinUI or of that platform, you know, and that's something that's, you know, inherent in the Microsoft MVVM way of thinking, and that also comes over into Flutter as well. I've seen that sort of coming over into Flutter a lot.
So what is the default, or I would say, I know that Google has a lot of videos on Flutter and the documentation on Flutter, or what is the recommended pattern to use when creating Flutter applications?
Well, to be completely honest, I don't think Google, I think Google is a bit agnostic. I think they're quite reluctant to push developers in any particular direction. They tend to give people the tools to do things the way they want to do. And inside Google themselves, as a company, there are many different individuals that you know, express different ideas about how to go about these things. So I don't think that there is a unified voice on how you should do these things. And if you look at the documentation, it kind of reflects that. It doesn't push you in any particular direction. Personally, I think for most apps, for the average Flutter app, the simple apps, widget testing and integration testing, they create a very, very solid foundation to test your app. And then you might want to supplement it a little bit with some unit testing for regressions and complex logic in functions and things like that that tend to go wrong. That's my thinking. And the Flutter community has not really embraced that completely. What I still see everywhere I go is unit testing first. So the go-to in any team is, when you start building something, is to build a few classes, follow the test first approach, to write some unit tests which validate those classes, and then sort of work your way up to the controller, which is where the meat of the tests usually are. If you look at any Flutter code base, like you've said, you'll have your view model, or in the Flutter word, it's block, BLOC, or similar kinds of controllers, and the majority of tests are around those, which carries forward the same problem that we've had in the MVVM layer. And the thing about that is, firstly, it does not test the UI. You're not testing the UI. There's no guarantees that your app is going to behave correctly, because you're testing the view model, not the app, right? That's the first problem. But the second problem is that you're never going to have full test coverage. It's impossible to reach full test coverage with unit tests only, isolated unit tests, because you're looking at, just from the sheer point of view of the amount of test code that you need to write, you need to write so many tests, hundreds and hundreds of tests, just for all of the basic, permutations and scenarios inside those controllers. But none of those tests are clicking the button or validating things, on the field and things like that. So for me, I think this is the issue. We can move. This is probably true also in the Swift world. So we can move to a situation where we can test the majority of the use cases. We can test everything, the app itself. But we're still stuck in this old way of thinking that we have to treat every piece of code as a first-class citizen, and push it through tests in every scenario, and isolate the logic in each of those functions. We still think that way, but it's not helpful for the software development process.
Yeah, as you said, like test and code itself is just a liability. It's not an asset. The less code, meaning also less test in the end, we write to completely test our application, or at least test the main parts of the application, then it would be more than enough. Just so that we have 2,000 tests which are testing nothing doesn't really mean anything in the end. When I'm building app, I focus on testing the actual heart of the application. So for a bank application, we already discussed, it will be, this kind of different kind of transactions, and all those things will be the heart of the application. And then you will, obviously writing the unit test, and then you will write the integration test for those parts of the application. And then finally the end-to-end test of happy paths, couple of happy paths for each feature. But writing tests, and as you said, in your Flutter case, it's like view model or the view controller, to use that to control your UI. And these are the tests that just piles up to be thousands and thousands, which doesn't really test anything in the end. And that is what I'm seeing also in our Swift community, that we have these tests. Now, sometimes testing the view model is perfectly fine. I think the good example is, if you're using the MVVM pattern and you have that hotels application where you have 10 different filters, then it will be a better idea to write the test so that your view model can filter it out, like whatever the result. So you can quickly test it with stub data or whatever kind of a data if you have unmanaged dependency. So that's perfectly fine. But controlling the events, checking drop-down list is selected, or toggling the toggle box and whatever toggle control through the use of the view model, that doesn't really make any sense to me. You can just do it by writing an end-to-end test, not writing an end-to-end test for that feature, but writing an end-to-end test like a little bit much longer path. So
Yep.
an end-to-end test can be when the user registers with a correct account, they will go to the login screen where they can log in with that new account, and then they will reach the dashboard. So it's a pretty long test, which tests one long happy path, and it's going to cover like a lot of stuff.
Yes. Yep. Yep. I agree with that. And the other thing about that is that the other thing that people don't really think about too much is that when a user uses an app, the state is going to be dirty. Right? Everywhere I read about testing, everyone says start with clean state. Make sure that the state is clean. Well, in a real app, the state is never clean. You're going to be using the app, and you're going to have cache. You're going to have things loaded into memory. You're going to reuse certain things again and again. When you're building a complex app, you start loading a lot of things into memory, and sometimes you don't release those things. Sometimes you need to dispose of items, and at the right time, and sometimes you need to hold on to them for longer for different reasons. These things all build up over time. If you just do a unit test and you're not considering all these things, you're not testing all of the different state that builds up in the memory of the application. Sometimes you need to write long tests that travel from one screen to another screen with navigation, and refresh the state or change various things. Like for example, if you're on one screen and then you want to change something in the settings, you should go into the settings, make that change, navigate back to the previous screen, and make sure that it's still working. Because many things about the state of the app could have changed during that process. If you isolate that and you only test a tiny part of that, you're totally ignoring all of the state changes that could have happened during that process of navigating. So yeah, again, isolation. Isolation gives you isolation, but it doesn't test the app. So I think both are good. They both have their place, but at the end of the day, you need to test the app the way the user will use the app.
Yeah, I think one interesting question comes from this is, at what point, because end-to-end testing can be done with just kind of like a manual testing also, hooking up to the real thing. So at what point a developer will say, you know what, this is enough. Now I actually need to write an end-to-end test. I wonder if it's like, if you are working on a very complicated scenario, like you have, again, with the hotels example, where you have like 30 different filters and then you are sliding everything. So if you do it like 10 different times manually, you're like, okay, I'm already like, tired. And at that point, do you decide that, okay, you know what, it will be a good idea to write an end-to-end test because I can't really test this manually. Each time I test it, it's going to take me like 10 minutes to test.
Yeah. Well, the way I answer that question is I look back to how I automated testing. I say to myself, okay, I am the QA person, so I run my own business. So if I build an app, I can't hand that over to somebody to say, test this for me, please. I can't do that. I have to make sure that the app is working. So the way I look at it is, all right, well, I need to run through some tests. I need to make sure that this app is working. And I ask myself the question, what's going to save me time? What's going to be more reliable, and what's going to stop the user from getting a shock because there's a new bug, right? That's the only question I really ask myself. Are there enough tests to make sure that the user can step through the workflow, go to all the different places? Am I confident that I can hand that over to the user and they're not going to get a nasty shock? And if, it doesn't really matter if it's some little thing that's hidden away in the UI that the user's not going to touch, then it's not as important. I need to keep the development process rolling. I need to be able to deliver new functionality to the clients quickly. I need to put it in front of them. But at the same time, the tests just need to make sure that they don't go backwards. So when I make a new change, that the functionality doesn't roll back. And that's really all that testing is about, from my perspective, is just making sure that I can get that released to the client without having to go through hours of manual testing. And that's pretty much how I look at it. And that's how I've looked at it since the beginning of my career, really.
Yeah. I think, I mean, for me, it's like on the complexity of the UI. If the UI is super simple, like an example will be just one text box where you can write the name of the movie and search for the movie, and it will display you the list of movies. And it's just one search. I mean, just searching by name, it's not a big deal. I can just write it manually and do it end to end. But now you can add more filters to it by searching by producer name, searching for the year of the movie, the genre of the movie. Okay, now I'm getting a little bit, I'm not confident enough, because there are like 5 different filters, and I can sort it, and I can okay, that's gonna be hard. So that is the time I should probably invest some time in end-to-end testing. I should obviously write the test for the logic of that filter, which is integration testing with some dummy data or real data, depending on the dependency criteria. But at that point, I would be like, okay, I need to write an end-to-end test to check these filters out.
Yeah. And I think this is where the concept of layering tests becomes important. For me, I try to minimize the amount of layering, because as you know, we've talked about, test code is a liability. So if you've got that redundancy there, that becomes a maintenance issue over time. The bigger the app gets, the more of a liability that redundancy will be. So you need layering to a certain extent, some redundancy across the tests, but I try to start with, you know, as coarse as possible tests, so that if I'm able to test those parameters through the UI, if it's not complicated to do that, then I'll do that. And one reason why that's good is because if you start at the unit test level, you have no validation at that point in time. You're not validating the input parameters before they hit that point in time. So to sort of go back to the MVVM situation, depending on how you design your code, you may actually have some validation over the top of your view model that stops certain scenarios from happening before they actually happen, right? So a text box, for example, may not allow textual characters, for example, right? You might have a classic case is you might have a text field that only accepts numeric characters, but at the view model level, you're accepting strings. So the temptation might be to validate against strings, right? But that can't happen in the real world, because it's a numeric only field. So if you're testing at the UI level and you're not testing at the MVVM level, then you know you've already solved the problem of textual characters. You don't need to solve that problem again. And so I start at that point. I start at the UI level, and then I layer as necessary. And even going, if we were to talk about a bank, I would do it exactly the same way. I would still start at the highest level, the coarsest level, and make sure that at the highest level it's working correctly, but then layer it with several other layers of protection over the top. And when we're talking about a bank, that redundancy is expected, it's normal, and you would expect to have hundreds or thousands of tests lined up and causing massive redundancy. But for a simple UI app that's in the App Store, this is a completely different thing.
Absolutely, yeah.
This is a great topic for me. So if we wanted to do another discussion and hone in on these some aspect later, I'd be very keen to do that. I hope it's been a solid discussion for other people to learn from.
Yeah, absolutely. Hopefully, yes.
I'd just like to say thank you for your time, and I'm really happy to speak to people if they want to reach out on social media and chat about this further. I'd love to talk about it.
Sure. Kristen, can you share how people can find you on social media?
Yeah. So best thing probably is just to check out my website, christianfindlay.com. I'm CF Develop on Twitter, or just search for me on LinkedIn.
All right. And everyone can find me on Twitter also at Azam Sharp, or visit my website at azamsharp.com. All right.
Thank you for your time. It's been great.
Yeah, thanks a lot. It was fun. And we'll definitely be recording more, talking about certain other aspects, testing, or other aspects of designing and architecture.
Great talk. Great talk. Thank you very much.